In this question, we've got two shapes, and the question states these two shapes are similar. So similar, meaning they are the same shape, but they can be different sizes, and the shapes are in proportion. So we've got to work out the similarity statement. A similarity statement names the shape using the vertex points and then puts a similarity between them. They use either three vertical lines. So let's look at the first on the left. We can start at A and then go around. We'll go around clockwise. We'll go around this way. And so that goes A, B, C, D. Cannot go A, B, D, C. Cannot go diagonal. Can't go A to B and across to D and down to C. That wouldn't work. So the next one is we've got to work out what does A correspond to. Now, this point here, A, corresponds to the 90-degree angle in the other shape. And there's only one 90-degree angle, and that's at E. So A corresponds to E. So I'm just going to put here A corresponds to E. So that means if A goes first, E has to go first. Oh, there are two 90-degree angles. Did we get the right one? Yes, it did, because this 90 degrees is attached to the long side, and this 90 degrees is attached to the long side. So that means that D corresponds to H. So let's write that down. D corresponds to vertex H, and then it goes down. The other 90 degrees is B, and B corresponds with F because they're both attached to the short side. So B and F are corresponding points, which leaves C corresponding to angle G. And you can see that the large angle at C and the large angle at G mean that C corresponds to G. Now we finish our part A and says that A, E, B comes next. So B corresponds with F. So we've got to put F second. C is third. C corresponds to G. So G must go third. D is last. D corresponds to H. So H must go in the last position. So we've got our answer for part A. By the way, there's a number of different ways you could have written A, B, C, D. You could start at any point. For example, you might have wanted to start at C. I'll just put or. There are many others. We could go the other direction. We could go clockwise. So C, B, A, D. It doesn't matter which point you start at and which direction you go. But it does matter that if C is first over here, G must be first over here. So B is second, and B corresponds to point F. So F must be second. A is third. A corresponds to E. So E must come third in the second shape, and D is last, and D corresponds to H. So H must be last. So there's many different answers for part A. Part B, complete the following. EH, side EH, let me highlight side EH. I'll just put a highlight EH. Gee, I've got a lot of EH. EH is this side here. All right, so if that's EH, then we're dealing with EH. We're dealing with side, if E goes to H, A goes to D. So we're dealing with AD over here, which is that side in the other triangle. So all you have to do is match. E matches with A. E matches with A, so you've got to write A underneath. So EH over A, and H goes with point D. So you've got to put a D underneath there because H matches with D. Now, Our second ratio, F to G must be B to C. So FG on top, BC matches FG. And I'll just put this green highlight FG. FG is over here. Oh, I don't like that colour. Let me change it. Let me change it to green. FG and BC. FG matches with BC. And that's part B. C, oh, again, I don't like that. Let me go to C now. Find the scale factor. Well, the scale factor is, well, do we know EH? EH, do we know, EH, where's EH? It's X, or we don't know EH. Can't use this one. Do we know FG? No, we don't know FG. Let's come up with two other sides. Well, what sides do we know? Well, if we highlight, don't like that colour for a highlight, F to E. So if I write F to E on top, and I use the second, for the numerator I use the second shape on the numerator, and the first shape goes on the denominator. So measurements from this first shape. FE matches, there's FE, F to E. Then we're dealing with B to A. Right, we know FE is 5. We know BA is 2. Good. We need another fraction with both numbers. No, we don't. This is good enough. FE is 5. BA is 2. Therefore, our scale factor is 2.5, which means if you multiply the small shape, this one, by 2.5, you will get the biggest shape. Find the value of X. Am I able to do this? Will it work? Can I make this bigger? I don't know. Let me try it. All right, let's put it up here. X is where? X is EH. X is this ratio. X is in this ratio here. So let me fill in. I'll just go EH over AD. That is going to equal 2.5 because we already worked that out. Now replace EH with X, replace AD with 3 is 2.5. Now divide 3 up to multiply by 3. Therefore, X equals 2.5 times 3. So our answer is 7.5. Do we need the centimetre? No, we don't, because it's already in the diagram. X is equal 7.5. And finally, I haven't left my space. I'm running out of room. Never mind. Value for Y. Y is DC, and Y is DC. DC is not there, so we haven't done DC yet. So DC and HG go together. So HG on the second shape, DC on the first shape is going to equal 2.5. And then we substitute. HG is 7. DC is Y equals 2.5. And then I really don't like that I've run out of room. So what I'm going to do is I'm going to eliminate that first answer I had because I've already got an alternative. That's not the only answer. There's many different answers for part A. So I'm going to put, you can rewind that if you want to see that again. So I'm going to put that as my one of my answers for part A. It's not the only answer. But let me carry on with this question here. I'm going to swap the y and the 2.5 over, so 7 divide 2.5 equals y. And so that's bringing the 2.5 down to be divide. Take the divide y up to be multiplied by 1. Therefore, on your calculator, what is 7 divided by 2.5? Can we do that? Hey Siri, 7 divided by 2.5?
7 divided by 2.5 is 2.8.
Thank you. So therefore y equals 2.8. And we're finished. Okay. I hope this has helped. Until we talk next time, stay happy.